So hello everyone, welcome to ETHIndia. Thanks for joining the Lighthouse workshop. I am Ravish and let's start. So at Lighthouse, we are building a perpetual file storage protocol on top of Filecoin, which provides you ability to pay once and store your files for a very long period of time. We are proud to be an active contributor in the Filecoin ecosystem for the past 2 years. Our key focus while developing the product has always towards being the developer. So that the developers can keep focusing on building their apps while Lighthouse take care of their storage needs. At Lighthouse, we have got Lighthouse files and Lighthouse SDK, which you can use to play around with the products and try out different features quickly. Along with that, we have Lighthouse JS SDK, which you can use to integrate into your applications. And since IPFS and Filecoin are public network, in order to maintain the privacy, users can use our Kavach library to encrypt the file while uploading it to the IPFS network. So let's have a detailed talk on the programmable storage. It's something different which you won't find in almost all the Web3 products as well. So suppose a person X wants to store the file with 2 replications. One copy should be stored in the United States and say one copy should be stored in India. It is possible with this just one line of code using the programmable storage modules of Lighthouse, and we will see shortly how it is done. So let's start building. First, let's have a tour of the file step. So if you go to files.lighthouse.storage, you will come to this UI. You can log in. You have the Solana option, EVM option, and Web2 logins like Google and GitHub. So I will be using the EVM option. So it will trigger my MetaMask. Let me sign in. And yeah, here is the dashboard. So you can upload the file, upload a folder. You can turn on the encryption, upload the file with encryption. If you want to import the file from IPFS network into Lighthouse, you can use the migration service. In order to use the SDK, you will need an API key, which you can generate from here. Suppose I want an admin key, so I write admin. I click on generate, yes, and here is my key. Also, we have 2 more ways to generate the API key, which you will check in the docs section. So if I come back to dashboard and I click on a particular file, so I get the file details. So this is the file size, it was created here. This is the CID, which is the hash of file. And if you go here, you will find the storage deal. Let me click on it. So it took me to the Philfox dashboard, and here I can see few details. Firstly, let's check the piece CID. So this particular piece CID is the CID of the entire bundle that was shipped to the Filecoin miner. And within that bundle exists my file, which is 0.55 kilobytes. Although the entire bundle is of 32 gigs. So what's happening is, at Lighthouse, we aggregate your files with files of other users to create a 32 gig bundle, and then we ship this bundle to the Filecoin miner. Okay. Yeah, also you can, if you want to view the file, you can just copy the CID, go to gateway.lighthouse.storage, paste it here, and here it is. Also, you can view the file directly on the dashboard. So yeah, some formats are not supported, but image and video files you can view it directly from the dashboard as well. Now coming back to the presentation. Okay, so this diagram depicts the entire journey of file from the user to the storage miner. When the user push a file to the from Lighthouse, it first gets stored in the Lighthouse IPFS node. From the IPFS node, you can instantly view the file using the gateways that I just demonstrated. And also, once the file is successfully uploaded to the IPFS node of Lighthouse, we have our deal engine, which fetches the file and bundles it with the files of other user. Once the 32 gig bundle is ready, this file gets shipped to the Filecoin miner and a Filecoin deal is ready. After that, you can see the Filecoin deal on the dashboard. So now let's go to the documentation. So you can go to docs.lighthouse.storage. You can have a brief overview in the intro section. In the quick start guide, you can see how you can get all the elements together and just upload a file instantly. Create an API key will show you the SDK method. If you are using any other programming language apart from JS, then you can use the APIs. So all the sections will also contain the API. So if you are building on Rust or Go, you can integrate using the APIs. And if you are using our CLI tool, you can refer to the CLI section. Then you can upload the data. In uploading the data, you can upload a file, you can upload a JSON, or upload a buffer. If you want to encrypt the data and then upload it to the IPFS, then again you can encrypt the file, encrypt the JSON, and you can refer to the encryption section. Along with that, we also offer some more features on encryption, like sharing a file. So if suppose I have uploaded a file with encryption, the other user, when he will be fetching the file from IPFS gateway, he will get downloaded a binary file, which he can't just decrypt. So in order to make this file viewable to that particular user, you can use a P2P share method. So you can just put his wallet address, do a authentication signature, and the file will be viewable to the other user as well. If you want to revoke the access from that user, you can refer to the revoke access section. Along with that, you can also use token gating. So in token gating, you can apply access conditions like, okay, unlock this file after this many block periods. Suppose you want to share file to your friends on his birthday. So you can do something like this. Or if you have a NFT collection deployed on any chain like Polygon, Ethereum, you can just create a condition like, okay, store if a particular user owns an NFT from my collection, then this file should be viewed from him. Something like this can also be built. So if you go to the access control condition section, you can see all the different kinds of conditions that you can try. First is the balance of. So in case you want to, this one is the NFT example. So you can just call the balance of method and compare if he owns the NFT or not. Then you have custom contracts. So if you have your own pre-built contract, you can just define the function that you want to invoke and match the parameters and then allow the decryption to happen to the other user. Then you can also match the native token. So if a particular user owns 1 ETH, then decrypt the file for him. Even something like that is possible, and the time-based conditions. You can go to the chain supported section to see all the chains that are currently supported. You just need to put their name in the access conditions. We will also be having look into this into further detail in the demo section. Let's explore rest. So list file, you can just use this to view all the files that you uploaded to Lighthouse. File info, you can check the metadata of the file, so file size, CID, whether it is encrypted or not, file name and MIME type. Next is get balance, you can just check the balance, so how much data cap it's left. Then you can use the retrieval directly if you want to fetch the file from gateway. Then in case your Filecoin deal is ready, you can just check the status of your deal and you will get something like this. So main is this chain deal ID. Chain deal ID, you can search it on the Philfox and you can get the information of this particular deal even on the chain. So in case, since CID is hash of a file, so if you even change a bit within that file, the entire hash gets changed. So in case you have a mutable file where the file is getting uploaded again and again, but you need a constant URL. In that case, you can use the IPNS service where the URL will remain the same. You just need to change the pointer of the hash. So you can refer to the IPNS section. It's quite simple, just 4 steps and it will get done. Then the migrate file, in case you want to import all CIDs in bulk from the IPFS network into the Lighthouse. Then we have got the pinning service. It works in case you have a single CID, you just want to pin to Lighthouse, you can use the pinning service. Pay-per-use will, so all the users are not comfortable in buying the entire, suppose 100 gigabytes at once. You just maybe have a storage need of 100 gigabytes that you want to store perpetually. In that case, we have built a service called pay-per-use where you can just get the quote, get the price for maybe suppose 100 megabytes, you just put your file size, then which network you want. Currently we support Filecoin mainnet and calibration net, and if you want to use native token, just type native, or if you want to use a stable coin, you can type USDC, and in case of calibration net, it's USDT. So, and you will get the price. Whatever price you get, you just put it here. You can just do the parameters, sorry, the fund function, and you can pay. Once you paid, automatically your data cap will get increased, and you can upload that much particular file. Maybe suppose 100 MB, 200 MB, whichever you want. And in case you just want the upload to happen in real time and you have not generated API key or anything, you can also generate a one-time auth token. It will get expired after the upload. Now resize image. So in case of gateway, if you are fetching an NFT collection and you want, suppose the file is of 19201080, the resolution is high and you want it to be 240 by 250 just to showcase it well in your site, and it also saves some space. So you can use this resize image where you can define the height and width of the file, and it will resize it and display it for you. If you are playing around with our CLI tool, you can refer to this section. Now let's upload a file. So I'm opening my VS Code. So I've already taken this code from our docs. So just to upload the file, you need two parameters. First is your file path, and second is the API key. So you just call lighthouse.upload, import the library, import the env variables, and simply give the absolute path, not a relative path, and provide the API key, and file will get uploaded. So if I just go to node index, and there it is. And if I want to view the file, I can just copy the hash, go to the gateway, replace the CID, and there it is. Okay. Coming back to the presentation. Okay, so now let's look into the programmable storage. So in order to use the programmable storage, what you just need to do is call this RAS worker, and rest of the things will be taken care by Lighthouse in the backend. So how it is working is, either you can submit your CID using our transaction in the contract, or you can call an API using post request. That I will demonstrate. After the request is registered with the RAS worker will take that CID and pin it to our IPFS node. After pinning, the deal engine will take that file and it will upload it to the Filecoin network. Okay, so once the deal is getting expired, and if you have set up a condition to renew the file, what will happen is the RAS worker will again pin the file to the IPFS network. So a file is repinned before the deal gets expired, and deal engine picks that file and again send it to the Filecoin miner. So before your deal is getting expired, you got another deal. So in this way, the deal is getting created perpetually. And we are also using this RAS worker quite extensively in our perpetual model. So if you want to use the RAS worker, let me go to the RAS code example. So I will close this. Okay, I closed the other one. Not this. Okay, so in order to register your CID, you just need CID, and even the rest of the parameters can be default. And if you want to define the parameters, you can do so. So I have created a signer, then I have created the contract object. The contract address you will find in the docs as well. And also I have pushed this code in my Git repo. You can find all the code examples that I'm demonstrating here in my GitHub. Then I've created the contract object. This is my CID, which I want to register. I have converted CID into hex. Now I'm calling the submit RAS function. So first parameter is the CID. Second is the number of replications, how many copies you want. Third is when the deal is getting expired. So if the miner is defaulting on a deal, he is not submitting the proof. So after how many epochs, if the default is happening, should the deal get renewed? Means our copy should get created with another miner. And final one is the increase the, so when the deal is getting expired, so you can define before how many days the deal gets expired, should the deal get renewed. So suppose on an average in a day there are 2880 epochs in the Filecoin network. So if you want to do it 10 days before the deal gets expired, you just do it 28800 like this, and this happens. So if so this one will take little time. So transaction takes around a minute. So to save the time, let's check the deal status and let's have a discussion on the pod side. So once your CID is registered in the test network, you will get a deal within 20 to 25 minutes, and you can check the status of your deal using this API. Everything is also in the docs. You can refer to the FVM section. So calibration.lighthouse.storage API deal status, put your CID. Okay, so for this particular CID, deal is already been created, and you will get a response like this. These are the current active deals. Then this one was the transaction ID. These are the deal IDs. You can, okay, let's check one in Philfox as well. So in case of calibration net, you go to deal and just paste your deal ID. And here it is. So you can check the Filecoin miner. The deal size is 16 MB. So in the testnet, the miner supports files from starting from 4 megabytes. So you can even create deals for small file sizes. So the transaction is done. You get a response like this. Okay, so once the deal is gets created, you can use PodSci. It's to get the file proof. So I will just give you an overview. What happens is we use this file proof data to recreate this piece CID, and this piece CID you can verify it on chain. It should match with this piece CID. So this means that the piece CID which is shown by us actually has an on-chain record, and using these file proof parameters, it proves that your file was part of this particular piece CID. In this way, you can be sure that, okay, in this 32 gig bundle, my file is also present. Coming back to the presentation, so we have already discussed the programmable access control in brief. So how it is working internally is we generate a random key at the user's end. That key is splitted into 5 shards, and those shards gets independently stored in 5 different nodes. Currently, these nodes are hosted by Lighthouse, but we do have our decentralization plan here as well. And we use this random key to encrypt and upload the file to the IPFS. In this way, you have an encrypted file uploaded to the IPFS network. In a similar fashion, the decrypt one, you just request the shards and generate the original key at the user's end, get the file from the IPFS network and decrypt it. Okay, we also have passkey feature in the encryption, where you can use your fingerprint, or from your mobile phone you can decrypt the file. In the documentation, you can find the passkey here in the authentication section. You can even refer to this. Next, pay and fill is the paper deal, which we just discussed. Now coming to the bounties. So we have 2 bounties. First is best use case of our programmable users functionalities, $2,000, and best overall use case of Lighthouse SDK is split among 2 teams, $3,000. Here are some common use cases. You can create perpetual renewable storage using this programmable storage, data DAOs, and time logged access conditions, and more. Okay, in case you have any query, you can ping me on Twitter, Telegram, or you can also write us on the Discord. This is the Lighthouse Discord, and you can even write us on the ETH Global Discord. Yeah, thank you.